Hello everyone, welcome to my YouTube channel. I am Vamshik Shetty, pursuing second year BE in Sri Venkateswara College of Engineering, bearing USN 1 VE 21 CS 183. Today we are going to discuss the major concept in microcontroller and embedded system, that is embedded system hardware. A brief introduction about the embedded system hardware is given here, whereas the embedded systems are designed to control many different devices. The embedded system control the many different devices. All these devices use a combination of the software and the hardware components. The software and the hardware components are processed by the devices in such a way that it processes at a particular time. Each component is designed to provide higher efficiency and is designed for future extension and expansion. The devices which are controlled by the embedded systems provide the higher efficiency and designed in a future extension and expansion. And now the ARM-based embedded system, that is also called as microcontroller, which is divided into four major components: the ARM processor, controller, peripheral, and the bus. A typical diagram of the microcontroller or the ARM-based embedded device is given here, in which all the devices are interconnected between the AHP and APB bridge. The AHP is known as the ARM High Performance Bus, and the APB is known as ARM Peripheral Bus. The controllers are divided into interrupt controller and memory controller, and the peripherals are given here: the real-time clock and the Ethernet, serial UARTs, counters and timers. All these devices are connected by the bus, and the components are given here. The ARM processor controls the embedded device. Different versions of the ARM processor are available to suit the described operating characteristics. An ARM processor comprises a core plus the surrounding components that interface it with a bus. These components can include memory management and caches. And the next one is controllers. Controllers coordinate important functional blocks of the system. Two commonly found controllers are the interrupt and memory controller. The peripherals the peripherals provide all the input-output capability external to the chip and are responsible for the uniqueness of the embedded device. And all the devices are connected by a bus to communicate with the different parts of the devices, that is controller, peripheral, ARM processor and all. And we can discuss about each component majorly. First, the ARM bus technology. Embedded devices use on one chip bus that is internal to the chip and that allows different peripheral devices to interconnect between the ARM core. The different peripheral devices are connected by the ARM bus technology. There are two different classes of the device attached to the ARM bus, that is a bus master and the bus slave. The requests given by the bus master are obeyed by the bus slaves. The bus slaves only obey the request that is obtained by the bus master. That is given here, that the logical device capable of initiating the data transformer with the another device across the same bus. And the bus slaves are the logical device capable only for responding a transfer of data or the request from a bus master device. And all the peripheral are the bus slaves on chip. ARM bus has two architecture levels, that is physical level and the protocol level. These physical level are the electrical characteristics and bus width of 16, 32 and the 64 bits. The protocol level covers the logical rules that are governed and communication between the processor and the peripheral. The physical level has the bus width of 16, 32 and the 64 bits, and the protocol level communicates between the processor and the peripheral systems. Moving on to the next, ARM bus protocol. This was first introduced in 1996 but widely adopted on the used ARM processors. There were the two ARM bus protocol, that is ARM system bus and the ARM peripheral bus. Later another ARM bus protocol was introduced, that is ARM high performance bus. Using AMPBA, peripheral designer can reuse the same interface design on the multiple projects. A peripheral can simply bolted onto the on-chip bus without having to redesign an interface for each different processor architecture. The AHP provides higher data throughput than ASB because AHP is based on the centralized multiple bus scheme and the ASB depends on the bidirectional bus design. So AHP provides the higher data throughput than the ASB. And the ARM has introduced two variations in the AHP bus, the multi-layer AHP and the AHP Lite. The original AHP, which is also called as multi-layer AHP, where the original AHP were allowing only single bus master to be active. But the multi-layer AHP bus allows multiple active bus master, where the original AHP provides only a single bus master, but the multiple layer AHP provides the multiple bus masters. Whereas the AHP Lite is a substitute of the AHP bus, it is limited to the single bus master. And the AHP Lite was developed for the designs that do not require the fully features of the standard AHP bus. And moving on to the next component is memory. An embedded system requires some form of memory to store and execute the code, whereas the data or the code can be stored in a place called memory in an embedded system. The memory should be fast, large, and inexpensive. Unfortunately, it is impossible to meet all the three requirements. The common solution is to have the memory hierarchy. The memory hierarchy is given in the following figure, whereas the performance and the memory size graph is shown as shown in the figure. And the memory width. The memory width is the number of the bits of the memory returns on each axis, which is typically 8, 16, 32 or 64 bits. The memory width has a direct effect on overall performance of the system. So memory width is also important in the performance of the system. If you have a system using 32-bit ARM instruction and a 16-bit wide memory chips, then the processor will have to make two memory fetches per instruction. This reduces the system performance, but the benefit is that 16-bit memory is less expensive. So if the core executes 16-bit thumb instruction, it will achieve better performance with a 16-bit memory. So if you are having the 32-bit ARM instruction and a 16-bit width memory chips, then the processor will have two memory fetches per instruction. So this will reduce the system performance, but the benefit is that 16 memory is less expensive. And moving on to the memory types, there are many different types of memory. The ROM, that is read-only memory, flash ROM, dynamic RAM, that is RAM means the random access memory, in that static RAM, dynamic RAM, STM RAM, that is synchronous dynamic RAM. So these are the major types of the memory. And moving on to the next component in the embedded hardware, that is peripherals. Mainly peripherals that is communicate between the outside world and the embedded system. So given that here that embedded system can be communicate with the outside world via peripheral devices. So a peripheral device performs the input and the output functions also for the chip by connecting to the other devices or the sensor that are off chip. So each peripheral device usually performs a single function and may reside on the chip. Peripherals are ranged from a simple serial communication device to more complex 802.11 wireless devices. So peripheral is a path between the outside world and the embedded system. It communicates between the outside world and the embedded system. So next, moving on to the next concept, controllers. Controllers are also called as the specialized peripherals that are found within an embedded system. Mainly there are two types of controllers, the memory controller and the interrupt controller. In the memory controller, it connects different types of memories to the processor bus. On power up, the memory controller activates a certain memory devices to execute the initialization code. It configures the memory timings and refresh rate of DRAM before it is accessed. And the interrupt controllers, when a peripheral or the device requires an attention, it sends an interrupt to the processor. If any processor wants an attention, it provides an interrupt to the processor. There are also two types of interrupt controller, that is standard input controller and vectored input controller. In interrupt controller also there are two types, that is standard and the vector input controller. And that's it. for this video. For more videos, please like, share and subscribe the channel. Thank you.